Happy Thursday, and thanks for tuning in. Today, Karen and I will share some lessons that we've learned in the process of doing 2 linked data projects that are being conducted at OCLC Research. They show us some useful ways to make the transition from MARC to linked data a little bit easier. Just as a side note, Karen gave a version of this presentation at the OCLC pre-conference preceding ALA Annual last June. So a little bit of logistics. I will do a few introductory slides to set things up for the deeper discussion. Then I will hand it over to Karen, who will walk through some examples of what we're talking about with multilingual bibliographic descriptions. I will then join in at the end to talk about an example involving audiovisual materials and then give the summary and open it up for questions. And just another FYI, I'm coming in from Dublin, Ohio, and Karen is coming in from San Mateo, California. So to get started, the message is fairly simple. To make good linked data, we need good data. And by that, we mean data that is structured, accurate, and everything else that's mentioned on the slides, all of that goodness that's mentioned there. Now, of course, you can achieve these goals with MARC, but they aren't an automatic consequence of current cataloging standards. So what we're going to walk through today is a set of examples and then arrive at a list of recommendations for converting MARC records to linked data more easily by following a few conventions that are already defined. So to get started, what do we have to do? Well, we have to make our data more machine readable, which is a strange thing to say, actually, given that MARC means machine readable cataloging. And there's a truth to that, of course. A MARC record is certainly more machine readable than a physical library card. But the problem is that it is only readable in library systems. And the record itself is only fully understandable to human readers. And so here's a very superficial mock-up, and we'll talk about some real MARC records in the next couple of slides. But it shows where we are now and where we need to be. So at the bottom, we have a simple bibliographic description. It's kind of more like a Dublin Core presentation than a MARC record, but we all know how to map to MARC from something like this. And so that's what we have now. The attributes are labeled, but mostly it's human readable rather than machine readable. And the rest of the picture describes where we need to be. We need to take that flat human readable description and turn it into a list of machine understandable entities and relationships. And so in this example, we have the entity William Shakespeare, we have the work named Hamlet, a place named New York, and so on. And there are relationships associated among these entities. And so William Shakespeare is the author of Hamlet, and you can read the rest there. So as we're doing this, why does this difference matter? Well, one reason it matters is that the entity relationship representation is machine understandable. And it's machine understandable, especially if we identify the entities in unambiguous ways. And as librarians, we already know how to do that. And with linked data, we're given additional opportunities to create unique identifiers for each of these things. A second reason that this is important is that in this representation, we're connecting our human readable description to the world. And it's the world outside what we can understand as readers and what librarians manage. And so, in other words, other groups besides the library community have things to say about William Shakespeare, and they know about New York and have things to say about that. So if we record this information in a common semantic web standard, we're setting ourselves up for the possibility that librarians can contribute their knowledge about these entities to the world, and other communities can enhance that with descriptions of their knowledge about that world. And so we can learn for example, that William Shakespeare and Hamlet are also described in various scholarly communities or encyclopedias or standard web resources such as Wikipedia or news organizations, and you can see the possibilities. So that's the overall program that we're trying to accomplish here. And getting down to the nitty-gritty of a MARC record, let's make this concrete and switch examples. And here we have a MARC record that describes The Tipping Point by Malcolm Gladwell, and it's got a lot of details in it. And as our modeling proceeds, we focus on some of the important entities first. And so to simplify this, let's just look at these, where we have the author and the title and a summary and some subject headings. And at OCLC, we have certainly done a lot of linked data work to translate these into RDF, but so have lots of other communities. And so how to do that is well understood. But a point that we want to make here is that the actual mechanical conversion of one record to a set of statements is not exactly what we're trying to do. What we're trying to do is think about these things in the world, like the tipping point, and we want to gather information about them and end up with something that is like a hub of authoritative information that is much richer than an individual bibliographic record like we saw in the original screen. So at OCLC, what we're doing is creating a work description of the library resources that the tipping point is an example of. And by mining WorldCat, we end up with a collective hub of all of the things that we know about that particular resource. And here's one result. It's the WorldCat Works representation. And now this is something very different from what we saw on the previous screen, because now it's entirely machine understandable, and each of these links refers to a source of information that is much richer than we can represent in one record. And so to start things off, we have a URI for the work description itself, and then all of these other URIs point to authoritative hubs where we can find out more about the topics and all of the other attributes that are listed there. So this is fully represented in RDF, and some of these other points here show that it can be delivered in different formats. So we can do the same thing with person. And starting from that same bibliographic record again, let's focus on Malcolm Gladwell instead of the book that he wrote. Now, since he's a published author, he's represented in authority files, and in fact, he's represented in VIOF, so he's represented in authority files throughout the world. And so we get this representation. And from VIOF, we can link outside the library community to Wikidata, because he's a popular figure who appears in other contexts. And here, through this simple link, we can identify additional attributes about him that are not in the library metadata. So we know what his gender is, for example, and we might know some things about his family relationships. Or there may be languages and typescripts that are represented in one but not the other. And since Wikidata is structured data that is produced from Wikipedia, we also have a human readable description and a photograph that's available from him. So now we've got something extremely rich, and we're also thinking about pushing the concept of authorities for persons even further and thinking about what we're calling a person entity. And with Malcolm Gladwell, the results may not be so obvious from what we have done before, but what we're trying to do is collect all of that information about him and put it together in a form that is viewable and readable, and you can interact with it in various ways. And that's all well and good, but where this really starts to pay off is when we have people who appear in the published record and in resources managed by libraries that are not in authority files yet. So think about journal article authors or the various creators and contributors to audiovisual resources who don't have authority files at all. And so our person entity can be viewed as a superset of authority file information that includes drafts of descriptions for people who don't yet appear in library authority files. So now we have something quite rich, these authoritative hubs, and we've illustrated how we would build them up for two of the entities that are important in library metadata. And there are other ones, of course, organizations, places, and other ones that you can see in any simple bibliographic description. And what we can also say is that these descriptions are much richer than any individual human readable record. And this data is essentially sampled to create things like the person entity view that we have here. But it's actually quite versatile, and it gives us the potential to create customized user experiences that we're only now beginning to explore. But to get there, of course, we have to have an abundance of good machine processable data. And to start the conversation on a deeper level, I'm going to hand this over to Karen, and she'll walk us through some examples involving translation.
Okay. Thank you, Dean. Let me get control first. All right. So I'm going to start with translations. The relationship of a work with an author and its associated translations with their respective translators is relatively straightforward. This diagram captures the relationship in two reciprocal links, one from the original Chinese book in the blue box through its property has translation, pointing with blue arrows to each translation in the red boxes, and one from each translation back to the original Chinese work with the red arrows through the property is translation of. A work can have any number of translations, and there can be multiple translations into the same language, as is shown here with the two English translations, and that's why identifying the translator is so important. Now, machine access to VF happens far more frequently than by human beings. To leverage all the work done by the OCLC Cooperative, we want to share the relationships we've established between original works and their associated translations with the semantic web. Here's a sample markup of an original Chinese work written by Gao Xingjian, a Chinese Nobel Prize laureate for literature, and one of the translations of his work into English. We marked this up with schema.org. There were two new terms we proposed, since accepted as a bib extension to schema.org, shown here, the translator and translation of work. The same process contributes to WorldCat work descriptions. The relationships we're establishing in VF also flow into WorldCat works over time. VF includes XA records. Those are actually what we refer to as police records. They're records we create to force records out of clusters that don't belong and merge clusters that didn't have enough matching points. An XA record indicates manual intervention, where we manually split clusters that represent more than one person or merge clusters that really represent the same person. So in this first case, two different Japanese names have the same romanization. Most sources do not include the kanji of either the author or the works, and the romanizations for the same title differed. So some entries were associated with the incorrect Murakami Haruki. The XA records we created split the two Murakamis apart and made sure they were associated with the correct titles. In the second case, my college roommate has written several different works both in the United States and France. Each source listed a different title, and we didn't have anything to match on except her name, so we ended up with three different clusters. She confirmed that she wrote all three, so the XA record merged them into one cluster. And in this case, it's a triplicate for another name, this time due to differences in how the same name is represented by different sources. And it's been reported. It hasn't been merged yet. Humans are still better at detecting these kinds of errors than algorithms, so we will continue to need a manual override. So let's go to some very concrete examples. It's lovely to see records that include a summary. To present information in the preferred language of the user, we need to know the language of the individual data elements, not just the language of the resource being described. The language of cataloging in a record can indicate the language of the free text fields, such as summaries. So when we transform these summaries text strings into RDF, we can provide language tags, allowing us to present information in the preferred language and script of the user. So we have mocked up what a display could look like from the content of WorldCat records. Here we've taken advantage that we have an English language tag summary of an Iceland fisherman, the original in French, displayed in an English interface and with a table of translations and translators of the work. This is the same record with a Chinese interface. Since we don't have a Chinese language summary, none would be shown. Now this is a record of an English translation of a Chinese classical work, a travelogue of a Chinese explorer around 400 AD, but it doesn't say what the original title was, only a note saying title also in Chinese. Well, this one is a little bit better as it gives the romanization of the Chinese title, but it's in a free text notes field. And this one gives the Chinese title in a uniform title field. Yay! Of course, I'd prefer to see the Chinese characters, especially since this isn't even the pinyin romanization we now use. But since we group these records into content clusters, it's okay that the other records don't have a uniform title, since this one does. Now, when we convert that information into RDF, we can state not only the English translation, but also state the work it is a translation of with the appropriate language tags. Now, this represents a kind of gold standard that makes it very easy for us to parse. It has a 041 field, indicating the language of the original. It has a uniform title of the Chinese original with the Chinese characters. It has an added entry for the translator with the role term. And, be still my heart, it even has an original title entry with a link to the WorldCat record for the Chinese original. Now, it's pretty rare to find an original title entry for translations. In April 2015, only 684,000 WorldCat book records had a 765 field. Only 12,000 of them had a subfield W linked to the original. So it's okay. I would be perfectly happy with a uniform title and an added entry for translations, for the translators. Now, Hans Christian Andersen, Snow Queen, which was originally written in Danish, has been translated into many languages. When records for translations do not include an added entry for the translator, we resort to parsing the 245 subfield C, using a very long table representing all the ways translator or translated by can be written in different languages. So the English translator is easy for us to spot, but we also need to identify, for example, translator in Russian and in Turkish, as shown here. In VF displays, and what is really nice, though, is when you do have the translator shown, always please use the role term. This is a particularly nice example because it not only has the 041, which shows the original in Danish, but it also shows the intermediate translation. This is a Danish translated in French that was then translated into Vietnamese. In VF displays, we're displaying the translators where we can identify them. This is really useful to distinguish the Snow Queen translations into English and into Swedish by different translators. Now, the subfield E terms are language dependent. This is the list of the most frequently used terms for translator in different languages with some variations. So we have traducción in French, but it's also shown in this table by its abbreviation TRAD. Now, this list doesn't even list all the typos we find farther down the frequency list. Using the subfield 4 code is language independent, TRL, and we can generate the appropriate labels according to the language preference of the user. Unfortunately, most of the 700 fields in WorldCat, 68%, have neither a subfield E or a subfield 4. Now, for further examples, I'm going to turn this over to my colleague, back to Jean, for starting with some examples with sound recordings. Jean?
Thank you, Karen. We're getting set up here. Okay, thank you. So the work that Karen and I are describing, the projects that Karen and I are describing are works in progress, obviously, and we're at the analysis stage, but they have some surprising similarities. And we discovered them, frankly, in the process of putting together this presentation. So the work that I've been thinking about with sound recordings harkens back to my interest in free text analysis, but there are other reasons why sound recordings are especially interesting right now. For one thing, they're very rich in entities and relationships, even if they aren't necessarily recorded in a machine processable fashion. A second reason, as this audience certainly knows, is that audiovisual materials are the subject of an important Library of Congress study which makes some recommendations about how to enhance BibFrame with vocabularies and models that will produce a better understanding, a machine understandable model of this data than you can induce from MARC records. And a third reason is that these kinds of materials are the textbook example of why library data needs to be put out on the web, because we have stuff to share about this data, but so do other communities of practice. And going forward, it would be great if we could link to it. So in this example, it's a very, unremarkable from the point of view of data, I suppose. It describes a work by Bobby McFerrin and Yo-Yo Ma, and it's a popular musician paired with a classical musician, and that's the WorldCat rendering of the underlying MARC record. And here's a snippet of the MARC record. So to point a few things out, there's a 100 field with Yo-Yo Ma in it. There's a 700 field with Bobby McFerrin. They're both identified as performers. And in the 511 field at the bottom of the screen, you can see that there's more information about Yo-Yo Ma and Bobby McFerrin, but it's in free text. And that's why I'm particularly interested in this stuff. So as this audience also knows, though, all of the WorldCat catalog records have linked data associated with them. And so you can look at the linked data at the bottom of the page and induce the model from it. But the model for these kinds of descriptions is sort of unsatisfying because it's missing a lot of stuff that is only human readable. There's information about the individual tracks, for example, that is completely missed. So if we look at the linked data model that is there, you'll have an indication of the creative work, the manifestation-like thing that the bib record represents. And then there's a work-like thing that represents different ways that this recording could be rendered as an LP or an audio tape and so on. But then beyond that, all of this rich information that you see here, and actually the information that you see in the original MARC record, but only in a free text field, is missing. And so all you get is the creative work with a list of contributors or performers, and that's it. And so you don't know who did what to which track, and really who did what to any creative work whatsoever. And so that first draft linked data model doesn't have enough machine processable information to do anything much more than this. And that's the problem that we're trying to solve. So One thing we note, though, and since this is still an analysis project, we haven't actually acted on this, but the site Music Brains actually has some very nice structured data for the individual tracks of this same recording, and they do a good job of recording this information for all of the materials that they try to include in their collections. And so we could imagine that a path towards a better description would be to somehow link to this. And then there are some benefits that accrue if we do that. One, obviously, is that this community has done a lot of the work for us, so we don't have to do it. And the second thing is that users who would come into a description of this object might be coming in through Music Brains, and they would be able to then link to the library description as well. And finally, it just is in a form that is much more machine processable, and we want to be able to capitalize on that in future work. So just as Karen did in her example, in her data, I would also like to work through another audiovisual description that is closer to being machine processable than the first one that I showed. And so here's, again, another fairly simple example. But if you look at the underlying MARC record, you can see some nice things here. So you've got a 100 record, 100 description, a bunch of 700 fields, 511 fields that have data in a form that is easily parsed. And there are some subtleties here as well that I'll point out. First, that this material is much more easily recoverable. Secondly, lots and lots of 700 fields. There aren't any role designators in this because the role designators don't get specific enough. And if all you said was that they were performers, the coding of the 511 field actually says the same thing, that it's that they're performers, and the 0 at the beginning in the first subfield is telling us that they're not stage performers, but other kinds of performers. Another thing is that in this example, possibly unlike the previous example, we have an obvious primary creator who's mentioned in the title as well. And we also have multiple opportunities in this record to record role data. And as Karen pointed out in her example, if you put role data everywhere that it would be allowed in free text or whatever, then you end up with a record that is actually very difficult to parse because the information may be inconsistent. And so here, the wise choice was made that you use the MARC record standard to its fullest and record it in a way that is consistent with the semantics of the field. So a research project that we're conducting right now is to try to understand how to get the additional, more specific role information out of the 511 field. And so here's an example of some of that output, and it's not as difficult to parse read as it may appear. So on the left-hand side, we have the marked up correct answers, what the parser should have found. And on the right-hand side, we have what it did find. And then the color coding tells us which way the parser messed up. And so on the left-hand side, we have Gene Ammon's tenor saxophone, and he was not discovered in the parsing results, so that was a miss. And so down at the bottom, we have Bill Cosby host. That's what it should have found, but since this is free text and there are a lot of ways to say things, it was actually listed as host for the evening, which would not be necessarily a useful description of host in a collection of information. So so now we've got some fairly good parsing results here, but there's one more thing that we would want to be able to do, which is to look at these role names and realize, well, a human has to look at something like Lonnie Hillier trumpet and infer that Lonnie played the trumpet rather than constructed, destroyed, painted, or whatever. You just infer that when you see it. And so some additional processing would have to be done there. But fortunately, in the semantic web, a lot of this work has been done for us through a link to Wikidata, so that we can know that a trumpeter, somebody who plays the trumpet, is often represented as trumpet in individual descriptions. And so by linking to Wikidata, we can get the role names in the form that we need to have. And at that point, we would have the information for what would be a much more satisfactory model of this work, where we can identify several creative works. So on the one hand, we've got a music event, the thing that was actually performed, then it was recorded in a certain way, and then it was reproduced in a certain way. And so that's what all of the different creative works represent there. But of course, the actual performance event is perhaps of greater interest here. And here, with this more specific role information, we can say that Charles Mingus played the bass, Milt Hinton did that, Charles Mingus had multiple roles, and you can spell those out. And so you can begin to see that there are multiple ways to contribute to multiple creative work, and you can keep them apart. And so this is the kind of thing that we're aiming for as we try to get a more descriptive machine understanding of the data that is encoded in these kinds of records. So at this point, these are two examples that we're working on right now, and we can see that there are lessons that are similar for both of them. And it turns out that you can arrange them in a hierarchy going from least machine processable to most machine processable, and those then represent a list of recommendations that we can make as we continue to create MARC records with an eye now towards turning them into linked data. So obviously what is least machine processable is free text, but if you have to use it, make sure that you use standardized conventions and terms. In the middle ground, there's this gray area where there are things that are algorithmically recoverable, but in order to do that, again, using the MARC conventions to say that the most specific fields appropriate for a descriptive task help immensely, because that enables us to assign schema performer rather than schema contributor, for example, or schema summary instead of schema description. So what this also says then is if you find that you're using 500 fields, that would then represent a task for future analysts to try to untangle that and try to understand what the meaning is. So, and finally, I think the recommendations that Karen and I are making as well is that if you obey the field semantics and avoid redundancy, that helps with parsing as well. And beyond that, since we're both looking for entities and relationships and roles, this says in many ways to use the recommendations that we've listed there, using uniform titles, using subfield 4s rather than subfield E's, using indicators to refine the meaning, and so on. So that's the end of our presentation. I should say, too, that this is one thread of work that addresses the question of how to make MARC data more easily convertible into linked data. But as we close here, I should mention that there are other activities going on as well, and one that I'll highlight is the Program for Cooperative Cataloging Task Group on adding URIs to records, and I can address this more in questions, but just wanted to let you know that that's also going on, and that would also be in the list of recommendations once the work on that committee stabilized. So to summarize, we walked through some examples of how you can get more structured, more ambiguous data simply from a MARC description without changing the semantics of the MARC record, and in fact using the semantics of the MARC record more strategically. And there are a list of resources, the data science page from OCLC, the book that we've recently published. And so at this point, I would like to open it up for questions.